So topic 18 is a little more involved, and so I'm going to want you guys to use your blue textbook, your study guide, to read up on some examples for topic 18. I'm going to go over the general information that you have to know. So we've talked about Lewis acids in the past. So you have to know that a Lewis acid is a lone pair acceptor, and a Lewis base is defined as a lone pair donor. So we're talking about lone pairs of electrons, right? When a Lewis base reacts with a Lewis acid, a coordinate bond is formed. It's called a coordinate bond, and we've talked about those before as well, if you recall. A nucleophile is a Lewis base, and an electrophile is a Lewis acid. So you can also call a Lewis base a nucleophile. Remember that from topic 10. And you can call a Lewis acid an electrophile. So you should understand the difference between a Bronsted-Lowry acid base and then a Lewis acid and base pair. In other words, if you recall Bronsted-Lowry acids and bases, they are defined by talking about a hydrogen being donated or accepted, whereas now we're talking about a lone pair of electrons being donated or accepted. So you need to be able to talk about both of those, the difference. In 8.2, it talks about doing some Ka and Kb calculations, the expression for the dissociation constant of a weak acid. So we're talking about weak acids and bases when we're talking about Ka and Kb. For a conjugate acid-base pair, Ka times Kb equals Kw. So again, remember we talked about that back in the SL section. The relationship between Ka and pKa is this formula. So again, similar to what we were doing in topic 8. And then the relationship between Kb and pKb is this formula. So you would be doing some calculations using these formulas with logs like you did in the previous section. Solution of problems. You are going to be required to do solutions of problems involving H plus ions, OH minus ions, the concentration of those, pH, POH. So you already did these four. You already did these in topic 8. And now we're adding, for the weak acids and weak bases, we're adding Ka, pKa, Kb, and pKb. So you'll want to be able to discuss the relative strengths of acids and bases using those values. So in other words, you need to, based on the information, you can verify that it's a weak acid or a weak base. The value of Kw depends on temperature, and the calculation of pH in a buffer solution will only be assessed in option D4. So you guys, if you were testing, you would have been responsible for this because of the fact that it is part of D4 and it is the option that we chose. Only examples involving the transfer of one proton will be assessed. In other words, you wouldn't be asked to discuss diprotic or triprotic, just monoprotic with one proton. That proton meaning H plus. Remember that is synonymous with saying H plus. And you would potentially have been asked to do calculations of pH at temperatures other than 298 Kelvin, which again, that's like room temperature. So they could have asked you for examples with different temperatures. And in any time that you are using approximations to do equilibrium calculations, you have to state that they are approximate, they're not exact. The next section, 18.3, talks about pH curves. And so the characteristics of pH curves produced by different combinations of strong and weak acids and bases. I'm sure that there's examples in your blue study guide that you should look at for that. An acid-base indicator is a weak acid or a weak base where the components of the conjugate acid-base pair have different colors. So this is where you would have gotten more in detail into the acid-base indicators, and we probably would have done a lab where you used something other than phenolphthalein, so that we have other acid-base indicators that we could have potentially used to study this this piece of 18.3. So other things that they want you to understand is the relationship between the pH range of an acid-base indicator, which is a weak acid, and its pKa value. You should have been able to select an appropriate indicator. Again, it's not always going to be, we use phenolphthalein with NaOH and HCl, but there's other acids and bases, and there's other indicators that can be chosen. And so based on our study of that, we should be able to pick different indicators for a titration given the equivalence point of the titration and the end point. So there's a whole range of indicators that can be used. And buffers. Okay, so for buffers, these are solutions that resist changes in pH when acid or alkali base is added to it. So I want you guys to know this right here. I don't know that we discussed this in detail, but another word for base is alkali. Okay, so these two words right here are interchangeable. So I want you guys to recognize that an alkali is also known as a base. Buffers typically involve a weak acid or base together with one of its salts. Okay, so that concludes the notes. There's a lot more details to this section that we would have to typically cover. I'm not going to go into too much detail, but I think that it would be beneficial for you guys to read the topic 18 section in your blue study guides.